Welcome to Battery Hacker. Have you ever thought about whether you're really using the correct number of batteries with a 1000-watt inverter? Many people make mistakes here, and those mistakes can damage the battery much faster than expected. In today's video, I'll walk you through the right way to size your battery setup. By the end, you'll clearly understand how to avoid early battery failure, and also how to figure out the correct wire size and fuse rating for this type of system. Earlier, when we discussed the setup for a 3000-watt inverter, we limited the current to under 100 amps by increasing the system voltage. Now, the question is, do we need to do the same thing again with a 1000-watt inverter? Let's calculate. A 1000-watt inverter running on a 12-volt system will draw around 83 amps. Since this is still below 100 amps, we can safely use a 12-volt battery here without needing to raise the voltage. Why do we always try to stay under 100 amps? The main reason is cost and efficiency. It saves money on thicker wires and reduces the size requirement for your charge controller. And if you're running multiple 12-volt appliances, like in an RV, staying at 12 volts makes the system simpler too. But here's the most important part: sizing the batteries correctly. If the battery isn't matched properly with the inverter's current demand, you'll face issues like overheating, wasted energy, and shortened battery life. So now, let's calculate how many lead-acid batteries are needed. A lead-acid battery usually has a discharge rating called the C rate of 0.2 C. This means that a 12-volt, 100-amp-hour lead-acid battery should ideally supply no more than 20 amps continuously. But from our previous step, we know that the inverter can pull up to 83 amps. If we try to run that much current from just a single lead-acid battery, it will be working way above its recommended limit. That's why we need multiple batteries in parallel. How many? Let's calculate. One 12-volt, 100-amp-hour battery equals safe output around 20 amps. Our inverter demand equals 83 amps. To stay within limits, we'll need 4 batteries in parallel. By wiring 4 of them side by side, the voltage remains the same at 12 volts, but the capacity increases to 400 amp-hours. This way, the battery bank can safely provide close to 80 amps, which is almost equal to the inverter's maximum draw of 83 amps. That makes the system properly balanced for lead-acid batteries. But what about lithium batteries? Lithium batteries usually have a C rate of 1 C. This means that a 12-volt, 100-amp-hour lithium battery can safely deliver 100 amps of current. If we compare that to our inverter's requirement of 83 amps, we can see that it's well below the safe limit. That means we don't need 4 batteries here. A single 12-volt, 100-amp-hour lithium battery is enough to run a 1000-watt inverter efficiently. Now that the battery part is clear, let's talk about the wire and fuse sizing for this setup. From our calculation, the inverter pulls a maximum of 83 amps. But we never size components exactly at the limit. We always add a safety factor. If we apply the standard 125% rule, the current requirement increases to around 104 amps. That means we need a wire capable of safely carrying at least that much current. In practice, the closest suitable option is a 2-gauge wire, around 35 square millimeters, with insulation rated for 90 degrees Celsius. A smaller wire like 3-gauge isn't commonly available, so 2-gauge is the safer choice. Next is the fuse size. The fuse should sit between the actual system current, 104 amps, and the maximum capacity of the chosen wire, about 130 amps. A 125-amp mega fuse fits perfectly here. Always go for reliable brands such as Bussmann, Little Fuses, or Schneider, because cheap fuses can fail at the wrong time and damage your system. Another tip, Keep your cable length as short as possible. Longer wires create voltage drop, which reduces efficiency and can put extra strain on the system. If you do need longer cables, you must calculate voltage drop and possibly increase the wire size. And that's how you properly size the battery bank, wiring, and fuse for a 1000-watt inverter running on 12 volts. With this setup, your system will run safely, efficiently, and with much less wear on the batteries. If you found this video helpful, don't forget to like, share, and subscribe to Battery Hacker. Your support really inspires me to create more useful content and guides just like this. Thanks for watching, and I'll see you in the next video.